Hello and welcome to another lecture. In this lecture we're going to talk about analyzing frame. We just learned how to do truss analysis using method of join and method of section. Now we're going to move over to frame and how we're going to analyze it. It's a really similar method we've been using. So just look at the example. As we go through the example, we explain all the different steps we involve to solve this. Let me bring the example up here. Okay, so we have this frame. It's actually a crane frame. As you can see, has the boom, which has a 10,000 pound hanging off of it. And I'm just going to read you the thing. Have a 10,000 pound. The crane is supported by a pin connection at A, down bottom right here, and a support at B, which is basically like it can move in the direction of horizontal. As you can see, there's a slot in there, and the member are the crane are pin connected. So you have a pin at C, pin at D, and pin at E. The member have weight, the following weight. Each member, they're really heavy. The post itself is about 1,400 pound right here, and the brace is about 900 pound right there, and the boom right there is about 1,500 pound. So they want to know, calculate all the forces acting on each of these three members. So what I do right here, let me close this out. This is the free body diagram. Take a look on the right. You can see the frame itself. This weight is given to us. And then it says, okay, the weight of the boom is about 1,500 pound, which is at the center. If this whole boom right there is at 10 feet plus 4 is 14 feet, so here's about 7 feet away. And then the weight right here also is down in the center right here at 900 pound. And then you have this weight right here at 1,400 pound right there. And again, this is being, if this is a 7, that'd be 3.5 feet from that line. What do you mean? So this distance right here, I forgot to put it down right there. From here, that's going to be, okay, from here to here is at 10 feet. Halfway is at 5 feet. So there's 5 feet right there. And just like a truss, we're going to go ahead and look at the external. After I put all these loads in, due to the weight of the member itself, then we kind of come in right here was a pin, so I'm going to replace it with AI, AY, and AX, and up here is basically like a roller, which is moved, so only have one restriction, and that's a BX. First, we're going to calculate these reaction forces, then we're going to go ahead and take out individual member and analyze it, just like do with the truss. So let's go ahead and take a moment about point. We can take a moment about point B or point A, doesn't matter. Let's take a moment about point B. Summation moment about point B is equal to 0. Counterclockwise is positive, and this is our sign right there, and we're going to follow that. So now I'm going to go ahead and start from here, work all the way back to this point B. This force has about 14. So it's going to be rotating clockwise. It's going to be minus 10,000 times 14. Okay, the next force I have is right here. It's a 1,500 pound, and that's going to be negative also, minus 1,500 pound time, that's a 7. And the next force I have coming this way is this 9,000 pound, and that's 5. So it's minus 9,900, I'm sorry, 900 times 5 feet. And this cannot take a moment, but here's the same line of action. This cannot take a moment, it's right on top of it. This cannot take a moment, a y about boy, it's the same line of action. So the only thing I have is the AX, and AX is going counterclockwise, is positive. So it's plus AX, and that's going to be 14 feet. Equals 0. So AX comes out to be Okay, I get 11,070 pound, and that's going to be AX is coming this way, it's a positive. Now I'm going to go ahead and use a summation f of x and summation f of y. Summation f of x is equal 0. Going right is positive. I have just AX 11,070 minus BX, they're all vertical, nothing else, equals 0. So BX on top is the same as f of AX, which is 11,070 pound. I calculate the vertical. Summation f of y is equal 0. Going up is positive. I have AY. And I got tons of minus 1,400. Coming this way, it'd be minus 900, minus 1,500, minus 10,000 equals 0. And AY comes out to be, next thing I'm going to do, I'm just going to take the boom itself and put it down here. So I have the boom. I got point C right here. So that's C. And then I got D right there. And then I have F right there. And then I'm going to put the loads on them. Add the 10,000 right here. And then down the center right here, we have the weight of the boom itself, 1,500 pound. And we know those are the same distance right here. And then another thing we're going to have to put in is point C right here. Because this is going up, that's a pin connection, so I'm going to have a vertical reaction this way, and then I'm going to have a vertical reaction going this way. And this will be CY, this will be CH. And point D, it's also a pin, so I'm going to go opposite of those. I'm going to go ahead and put DH, and then I'm going to go up DY. Distance right here is 4 feet. And from D, so this is 7 feet. And it's going to be 3 feet right here. We got everything. So now we're going to take a look at this as a rigid body. I took this part. It's a rigid body. That means it's not going to move. I can do the same thing I do like with the truss. I'm going to take a moment about point C because I got 1, 2, 3, 4 unknown, and I only have 3 equations. The equations that we talked about, we have summation f of x is equal to 0, summation f of y is equal to 0, summation moment is equal to 0. So now we have those, and we got 3 equations, 4 unknown, but 2 of them are concurrent, so we can easily solve it. Let's take a moment about point C. Going counterclockwise is positive. Start from this end, and I'm going to rotate clockwise, so it's going to be minus 10,000. And that distance is going to be 4 feet from here, and 10 is 14. And I have nothing else. I come over here. DH cannot take a moment about C because it's the same line of action. So the only one is DY can take a moment, and it's going to be counterclockwise, so it's going to be plus DY. And the distance from here to there is 10 feet. Am I right? Yeah, 10 feet. Then I have this one. It's going clockwise, so it'll be minus 1,500 times 7 feet. That's right. And these cannot take a moment about itself, equals 0. And all I have is a dy. So dy comes out to be 15,050 pound. So that's dy right there. And now we have this 15,050. Rest of it is easy. We can go ahead, because we use one of these, we can use the other one to solve the other member. So let's go ahead and do summation of f of y is equal 0. Going up is positive, I got minus 10,000. I got plus 15,050. I got minus 1,500. And I got minus CY is equal to 0. And CY comes out to be, okay, I assumed CY is going down, so the number comes out positive. That means my assumption was correct. So CY is going to be 3550 pound, and the direction is down. Okay, now I have this, I have this, I have this, and if I do summation f of x here, I have minus CH plus DH, or I should say, let's make that x. I don't know why I put h. Horizontal. CX dx. Let me correct this. Make this x. dx cx. So cx is equal to dx. We don't know what it is. So now we have to do what we're going to do when we take this member. Hopefully we can find out cx, and then we dx, and then we can know what cx is going to be. Let me erase this, then we're going to focus on this member. All right, so I'm going to take this member right here. Let's put it in here. That's that member. Actually, and I have point D here, and I have point E right there. I have a load in the middle right there, and that's 900 pound. And then I have two loads right there, which we already figured out. One was coming this way. Let me put them in different color. We had one coming this way, and that was dx, and one coming, that was going up, I think. It was d of y is equal x. Remember, when we had it before the other one I erased, these would go in the opposite, because when you separate them, you're going to go opposite and equal. Like in here, I had dy going up and dx going this way, but when I come in and make this connection right here, the reaction on this side is going to be these two, but the opposite way. That's why I have them shown opposite way right here. Same thing here. So now we got this, and now we have this. From here to here is a 10 feet. We know that. So from here to here is a 5 feet. And from here to top here is also 10 feet. So now we have that, everything. It makes it so much easier. I'm going to take a moment about point E. Let's take a moment. Summation moment about point E is equal to 0. Counterclockwise is positive. So we did this one, which we figured out. With this one, we figured all the one out. And now we're going to do the post itself. Let's do the post right here. That's from point from B. B, then we have point C right here. C, and then we got point A down here. A. And we can put the load on it too. We had BX right here, which was 11 0.70 pound. Remember, we got CX this way, so in here we gotta go the opposite. So there's the CX, which is 15,500, and then we have CY. Our CY is gonna go up like this, and that's going to be, what do we figure? A CY came out to be 3550. Let me just separate this right here. Then we have nothing else. Do we have point E actually right there? And point E we had EY, so our EY is gonna have to come down, and that was 15,950. And then we had EX, which is going that way. Ours is going to come this way, therefore. And our EX came out to be 15,500. And AY came out to be 13,800. And this one came out to be 11,070 pound. So the only unknown we have is, they're all there actually. And these are all the members. We did all the forces everywhere. So let's go over this one more time. We took the whole thing, we did a free body diagram. And free body diagram, when we put all the weight of the member in, including the weight was hanging from the beam. And then we took the external reaction. We found the external reaction, this one and that one. Once we had the external reaction computed, we took each member apart. We took the boom by itself, which we did it. We took this bracing by itself, which we did it, and then the post. And there we have all the number. I hope you like this video. If you like it, thumbs up or subscribe. Have a good day.